Hello everyone, and a very warm welcome to you all. My name is Dr. Mohammed Aoudi, and it's truly a pleasure to be here with you as we embark together on this exciting journey, Programming 4. This course will build your practical and theoretical skills in object-oriented programming using C#, one of the most powerful and versatile programming languages in the world today. Throughout this semester, we will explore how to structure programs, design efficient methods, manipulate data, and interact with the user through console applications, and much more. Whether you are already passionate about programming or just starting to find your path in the world of software engineering, this course will provide you with a strong foundation that you will carry into your future projects and careers. I encourage you to stay curious, ask questions, experiment boldly, and most importantly, enjoy the creative journey that coding offers. So without further ado, let's jump into our first topic, an introduction to C#, and let's start writing our first simple programs. Over the coming weeks, we will build your foundations in professional programming practices, object-oriented concepts, and practical application design. Programming is not just about writing code. It's about thinking logically, solving problems, and building systems that make a difference. So buckle up, stay curious, and let's get started with our very first session, an introduction to C# programming. We'll start by learning its basic structure, writing our first programs, and understanding how C# fits into the broader software development world. Here's a quick overview of what we'll be covering today. We'll dive into methods, their design, parameters, and behaviors. We'll also explore console class methods for input and output, math methods, type conversion, formatting techniques, argument passing mechanisms, string manipulation, and an introduction to .NET namespaces. It's a lot, but don't worry. We'll take it step by step, and by the end, you'll have a strong, practical grasp of how C# programs are built. Let's start simple. Here's our classic Hello World program in C#. This tiny program introduces critical concepts, using directives, the main method as the entry point, and outputting text to the console. Notice how structured and clear C# is. That's one of its greatest strengths. Now let's add a bit of interactivity. Here we ask the user to enter their name, and then we greet them personally. This introduces the concept of user input, using console.readline and string concatenation to customize output. Methods are the heart of any C# program. A method groups statements together to perform a specific task. Every C# program has at least one method, the famous main method. We can also define our own methods to break down problems and reuse logic. Modifiers are important as they control access to these methods. Common types include static, public, protected, internal, and private. Choosing the right modifier ensures your methods are accessible as needed. Access modifiers determine who can see or use our methods and variables. Let's quickly go over this table. Public means access is fully open, inside the class, child classes, and even from other projects. Protected internal means either inside the same project or a child class. Protected allows only child classes, even if they are from a different project. Internal is visible only inside the same project, no external access. Private protected is even stricter, only child classes inside the same project. And finally, private is the most restrictive, only the class itself can access it. Think of it like building walls around your code. Public leaves the doors wide open, private locks everything inside. The static keyword is very important. A static method or field belongs to the class itself, not to any object instance. Our main method must be static because it is called before any objects exist. Think of static methods like math_square root 25. You don't need to create a math object to call sqrt square root. We can also have static fields, which are shared across all instances of a class. In this example, counter is a static variable, accessible directly from the class, without needing an object. Static members are essential for scenarios where shared data or utilities are needed. Every method can either return a value or return nothing. Void means the method performs an action but returns nothing. Otherwise, a method can return types like int, double, string, or bool, depending on the task. Return types make methods more flexible and reusable. Methods can take parameters, input values that customize their behavior. Every parameter must have a type and a name. For example, addNumbers int a, int b takes two integers and returns their sum. Parameters make methods dynamic and adaptable. Let's apply what we've learned. This example shows a program that calculates the square of a number. It uses key concepts, using the system, console for easy input, output, defining a namespace, using the main method as the entry point. Here we see a complete simple program inside a namespace called square. Notice the structure. We define a class square example. Inside it, the main method is declared as static, so it can run without an instance. Then, we create another variable result that stores the square of that number, simply by multiplying a value by itself. The result is displayed using writeLine with a formatted string that clearly shows the calculation. Finally, read key is called to pause the program until the user presses a key. This tiny example captures a lot of important C# basics: variables, arithmetic, string formatting, and user interaction. Naming methods properly is a big deal in professional programming. A method name should immediately tell you what it does. Here are the basic rules. Start names with a letter or an underscore, never a number. Avoid reserved keywords like class or int. Stick to letters, digits, and underscores only. And most importantly, use Pascal case. Capitalize the first letter of each word. For example, calculate total amount is clear, professional, and easy to read. Good naming habits make your code understandable, maintainable, and a pleasure for other developers to work with. Let's look at some real examples. Calculate sales tax clearly says it calculates tax. Assign section number tells us it assigns something. Display results obviously displays something. Notice they all start with an action verb like calculate, assign, display. Follow Pascal case with each word capitalized, are short, clear, and descriptive. When methods are well named, code becomes self-documenting. No need for extra comments to explain what's happening. Methods can also receive external information, and that's done through parameters. Parameters are written inside parentheses after the method name. Each parameter has a type and a name, for example, int miles traveled. This allows the method to behave differently depending on the input it receives. Parameters are essential because they let us reuse methods for different situations without rewriting the code every time.